Hello guys, welcome back to Maison African Motives, still on Mechanotechnics N4. In this platform, we shall be having revision on belt drives. That is from the question paper, which was written in November 2022. Yeah, so we've got 14 marks on question number 2 on belt drives. So we shall see how we're supposed to obtain these 14 marks that we are given there. All right, so we are not going to waste much time, guys. We shall quickly rush through the questions so that we can see how we're supposed to attempt these typical questions. So we are given that the following particulars apply to an inclined belt conveyor. Take note, this is a belt conveyor, which means we are referring to a conveyor belt in this case. All right. So we've got the angle of incline of the belt conveyor, which is 14 degrees to the horizontal. Take note, if you are given a conveyor belt, you'll be having something of this nature here. Okay, let's just hope I'm going to have a nicer diagram. All right, so you're going to have something of this nature. So this is to the horizontal, which is to the ground. All right, something like this. All right, so here we have got our perpendicular height. So if we are to take into consideration, we are going to refer to the distance of the belt in this case, whereby we are given that the distance, the inclined length is 115 meters. So here we've got 115 meters. So the angle of inclination, which is the angle between, that is our theta, which is 14 degrees. So we've got 14 degrees here. And this is our edge. And remember, this is a right angle triangle. So you can even apply your trigonometrical ratios. So you are going to see that from the ratio of sine of theta, because this is opposite and this is the hypotenuse. So you know that the sine of theta is equivalent to the opposite over the hypotenuse. So that means we are going to have the sine of theta, which is 14 degrees, is equal to the opposite, which is this height h. All right. So we are going to have this h over, so in this case, we just say x or something else, okay? But the perpendicular height now, which is in this case, we are referring to h. Oh, sorry, we are referring to h, which is the hypotenuse, not the perpendicular height, guys. It's the hypotenuse, that is 115. All right. So if you cross multiply, you can have your h in this case, that's 1 times h, which is h is equivalent to 115 times sine 14. So this is going to be 150 sine of 14 degrees. Or you're supposed to know that your h is equivalent to the distance sine of theta. Okay, if you know that, then it's an advantage. Okay, so this is your height here, which is 115 sine theta, which is sine 14 degrees. Okay, so we have got the perpendicular height. All right, so what else are we given? The speed at which the belt moves. Okay, so this is your velocity. So this is your velocity. The contact angle, all right, so take note, the contact angle is the one that is referred to as theta. Okay, this we can just say it's alpha. Then there's a contact angle, remember that one that you use on the ratio of T1. Remember from your T1 over T2, which is equivalent to E to the exponent, that's E to the exponent of micro theta, like this, where this is the coefficient of friction and this is the angle of contact. This theta is the one that we are referring to. All right, and this theta is supposed to be in radians. So that means there is a conversion to there is a need for us to convert the theta that we have the angle of contact, the 210 degrees, to radians. All right, so we're going to convert our theta to radians, where we know that theta in radians is equal to theta in degrees over 57,3. That is going to convert radians. So our theta in degrees is 210. All right, is it 210? Yes, that's 210. So we have got 210, all right, degrees over 57,3. So you're supposed to use your calculator, guys. So please make sure that you use your calculator properly. You're going to obtain something like 3,665 in radians. All right. So we've got our theta in radians. All right, let's see the information again. Then we are given that the force exerted, that is the force needed to overcome the belt friction, is 4,100 Newton. So we are given the frictional force in this case, which is 4,100. So this is your frictional force, which is 4,100 Newton. All right. So the other thing that we have is the coefficient of friction, 0.2. All right, so for the coefficient of friction, which is 0.2. All right, so this is 0.2. So this is the whole information that we're given. So from this information, the question is, if the belt conveys 420 tons of rock per hour. All right, so take note, this is mass per hour. So we are given the mass of 420 per hour. So take note, we are going to convert this mass, is supposed to be in kgs per second. All right, so the mass, we are given the mass per hour, which is equivalent. We have got 420 tons per hour in this case. So we can convert to mass per second, which is kg per second. So remember that in a ton, we've got 1,000 kgs. So to convert this, you multiply by 1,000, which is going to be 420,000 kgs, all right, over 1 hour. We know that 1 hour in seconds, this is 3,600 seconds, all right. So that means if you divide, you're going to have mass per second, which is 116,667. All right, so this is what you're going to have as your mass per kg. So we've got mass, we've got the mass per time. Okay, so this is mass per unit time, mass per hour. Okay, so mass per second. So we've got this 116,667 kgs per second. We shall see. The application is simply tells us that we have got a mass. This is our mass per unit what? Per unit second. All right, so this does not even affect our calculations. All right, so the question is to calculate the following, which is 2.1, the output power needed from electric motor to drive the system. Okay, the output power. All right. This output power that we are referring to, when you are dealing with a conveyor belt, is the total of two powers that we are going to have. All right, so let's just see. Okay, so this is question 2.1. Is it 2.1 or 2.11? All right, so this is 2.1. Okay, so we know that the total power, all you need is to know your formulas, guys. Okay, the total power is a combination of two powers, which is the gravitational power, which is the power due to gravity, and also the power due to the frictional force. So this gravity is just simply the potential, okay, the potential energy. Remember, energy is power. So we are simply referring to the potential energy, and we know that potential energy is equal to mgh. But remember, there is an angle, so it is going to be mgh sine of what? Sine of theta. All right. The frictional power, which is the power due to friction, this one is going to be taken from the frictional force. Remember, we've got a frictional force here. So this is going to be the frictional force times velocity. Remember, force times velocity gives you power. All right. So you need to calculate the power, which is due to the what? To the gravity, which is the potential energy. All right. So let's just calculate let's just have our calculations here. So PG in this case, we said is mgh sine of what? Sine of theta. So that means PG is going to be M. That's the mass per second, which is the mass, the kg per second, 116.667 times the gravitational acceleration, which is 9.81 times the height sine of theta, which is the one that we referred as 115 sine of theta from this inclined part of the conveyor belt that we had. So that's 100 and what? 115 sine 14. Okay, so this is going to be 115 sine of 14 degrees. Okay, so all you need, guys, is to use your calculator properly. You're going to obtain something like 3,184, 24607, and so on. All right, so this is your power in watts, of which you can convert to kilowatts if you want, or you can leave your answer in watts. Okay, so if we are to convert to kilowatts, we are going to divide by 1,000, which is going to be somewhere here. So it is going to be 31,841. All right, so this is what you're going to have in kilowatts. All right, so take note, we have this power due to the gravity, which is our potential energy. Then we need the frictional power, the power due to the friction, which we said is PF. So we said in this case, PF is equivalent to the product of the frictional force times the velocity. All right, but do we have the velocity? Okay, let's check. Do we have the velocity? We do not have the velocity in this case. All right, so if we are to check here, all right, let's get back to this information. The speed at which the belt moves, okay, we have it here from this formula, all right, from this information. So we've got our V, which is 2,2 meters per second. So we've got our V there, all right. So that is going to be the frictional force times velocity. So we shall have this as PF, which is the frictional force, 4,100 Newton times the velocity. We said this is 2,2. All right. So if we multiply properly, we are going to obtain 9,020 watts. But take note, since we are to add these two, we must have the same units. If you want to add in watts, you must have this in watts. If you want to add in kilowatts, that means you are supposed to convert this answer to kilowatts. So by dividing by 1,000, we are having our answer in kilowatts, which is going to be 9,02 kilowatts. Okay, so this is the power due to the friction that we have. All right, so we have the two powers that we needed. So in this case, we can calculate our total power, which is the output power in this case, PT, which we said PG plus PF. Our PG, that is in kilowatts, 31,841 kilowatts plus 9.02 kilowatts. So that means your answer is going to be in kilowatts. All right, so the total power is going to be 40,861 kilowatts. All right, so as you can see, these typical questions, like if you've got questions like this, it's an application of formulas. You need to know how to apply your formulas. Your formulas, you have them, then how to apply. That is the concept. All right, so that's what we had on question 2.1 of the question on this conveyor belt. So we are now moving on to question 2.2, where we are given now to calculate or to determine belt tensions, which is T1 and T2. All right, so where can we have this information? We do not have T1. All right, we want to find T1 and also we want to find T2. All right, so what can we do? So all you need, guys, is to combine, to have information that can actually help you. Okay. The first part that we have that I indicated here is the ratio between these two tensions, T1 and T2 from the tight side and the slack side. All right. So using this ratio, that means we can play around with this ratio. Okay, let's just write this aside. This is 2.2. All right. So on 2.2, we can even just write it down here. All right. So let's just have it aside here. So this is question 2.2. So remember, we want to calculate T1. Also, we want to calculate T2. But so far, we have a formula for the ratio for these tensions, T1 over T2, that's e to the exponent of micro theta, where this is your coefficient of friction and theta is the angle of contact. So in this case, we do not have any, so we can just have a ratio between T1 and T2, all right? By substituting into this information, all right? We can see that T1 over T2 is equivalent to e to the exponent of, we've got this coefficient of friction. Remember, that was 0,2 from the information that we are given here. We listed, okay, here we said 0,2, all right? So that's 0,2 in this case. We're going to substitute the exponent of 0,2 times, all right, that's 0,2, not 0,4. 0,2 times theta. Remember, I told you that this theta is supposed to be in radians. So we are taking the answer in radians. For that, we converted here. Remember, we got 3,665. So you're going to multiply to 3,665. So that's 3,665. All right. So that means T1 over T2. If you are to simplify, this is just direct from your calculator E. That is from your calculator, okay? Second function lean, you've got your E. Then you raise to the exponent of 0,2. The answer that I'm expecting you to have is something like 2.0 0.081. All right. So from there, we can just have a ratio of T1 and T2. If you can cross multiply, both this is same as over 1. So you can cross multiply 1 times T1. That's T1 is equal to 2,081 T2. All right. So we have now a ratio of T1 and T2. So we can just take this as our formula, as an equation. So you can just say we've got equation 1. Because this, we've got two unknown values, so there's nothing that we can do. All right. The second part is we must have another formula again that has got T1 and T2 so that we can solve these equations simultaneously. But which information? All right, let's get back to our information. Remember previously here, we calculated the power, right? We calculated the total power from the total of the what? Of the gravitational force and the frictional force. But we can have this total power in terms of T1 and T2. Remember that there is this formula, so I'm just going to write aside so that we can understand what I'm trying to say. Remember that there is a formula that the total power is equivalent to TE times velocity, whereby TE is the effective tension, which represents the difference between T1 and T2. That's T1 times T2 times velocity. So that means we can have another expression for T1 and T2, okay? If we can divide by V both sides, that means T1 minus T2 can be given as PT over V. All right, where PT is the total power, the one that we obtained. So you can use this power. That was 40,861 kilowatts. Remember, kilo, that's 1,000. So it's going to be times 10 to the exponent of 3. So we have got 40,861 times 10 to the exponent of 3 over the voltage, okay? I'm sorry, the velocity. So guys, this thing of teaching many subjects, okay, this is your velocity. And remember, we had a velocity of 2,2 previously, the one that we are given here. Our velocity, we wrote it somewhere. All right, it's still on the information. This thing of not writing every information it affects. Okay, here, that's the speed, okay, which is 2,2 meters. So that's your velocity. All right, so that means we can have an expression or an equation from these two. All right, so let's simplify and see. So T1 minus T2, which is the one that we are worried with, is going to be the resultant that we find by dividing these two, which is going to be 18573. Okay, so we're going to have 573, 182. All right. So this is an equation for T1 and T2. But we can see that already here we have a T1 in terms of T2. So that means we can make T1 the subject from this formula. Okay, from this one, we can make T1 the subject, then substitute in what? In equation 2. All right. So how can we make it T1? We can just transpose this, then we equate. Okay, what I'm trying to say is that if we can have this equation as T1 is equal to T2 plus 185.3,182. You are going to equate these two, all right? Then you can find what? Your T2. Or since already here, we have our T1 as the subject, we can take this as an advantage. Already here, T1 is equal to, all right? So let me just write, this is our equation 2. From your equation 1, already T1 is the subject, which is equivalent to 2,081 T2. So in place of T1 in equation 2, we can substitute. So substitute T1 from what? From equation 1 into equation 2. All right, so we're going to substitute into equation 2. So that means T1, which is 20, 2, so it's going to be 2,081 T2, all right? Minus this T2, because we have substituted T1, so T2 is going to remain as it is, which is equal to 18573.182. So as we can see, it's a normal equation where you can subtract and solve for T2. Remember, this is same as 1. So 2, this minus 1 is going to be 1,081 T2, which is equal to 18573.182. So to find T2, we can simply divide by this 1,081. So if we divide by 1,081 both sides, we shall have our T2 as 17 181 and so on. Okay, so I'm just gonna leave this as 17,181, of which you can round off with those decimals. It's fine. There's no problem. Okay, so this is our T2. So to find T1, since here we wrote that T1 is equal to 2,081 T2. Therefore, our T1 is going to be 2,081 times T2, which is the one that we got here. That's 17,181. So if we multiply these two, we shall obtain our T1, which is going to be something like 35,755 Newton. All right, so this is your T1 and that's your T2. All right, so that is how that's how you play with these questions. If you are given belt drives, it's all about formulas, and you must manipulate each formula to find exactly what you want to calculate from the given question. So that's how you play around with these typical questions. All right, so that's what we had, guys, from Meson African Motives, still on Mechano Techniques and for till we meet again.